Hello, welcome to my exam video 5. In this video, we'll be talking about the various types of mutations on a given DNA strand. Here's a DNA strand given to us. The first thing that we'll have to do is find the coding strand and template strand. In the prompt, we are told that the coding strand will produce a 5 amino acid chain. So up top, here's our DNA sequence that I've copied from the other page, and we have to find out whether the top strand is a coding strand or whether the bottom strand is a coding strand. So I've copied the top strand, which goes from 5' to 3' right here, and this is the mRNA sequence that is transcribed. And here we can see that there's only 4 amino acids that are being formed. Now I took the bottom strand, which goes from 3' to 5'. I've reversed it into 5' to 3', and here's the mRNA sequence that is transcribed from the 5' to 3' DNA sequence, the bottom strand. And here we can see that there are 5 amino acids being formed, so therefore the bottom strand will be our coding strand. Now let's apply our different mutations to the coding strand and what effects it will have. The first mutation we'll be talking about is a missense mutation. The DNA coding strand is here, and this is the mRNA sequence that is transcribed. The mutation that is happening here is that guanine is substituted with cytosine, which turns the amino acid lysine, which is normally produced, into asparagine. This mutation is a transversion because guanine is a purine and is getting substituted by cytosine, which is a pyrimidine. Now let me visualize this mutation in a better way using UNO cards. As you can see here, the 5th UNO card is a different color, which is what I'm using to represent a different amino acid. Normally there would have been a blue 5 or lysine. After the mutation, there's a green 5 or asparagine. The second mutation that we'll be talking about is a silent mutation. The mutation is caused because guanine is substituted with adenine, which has no effect on the amino acid sequence. Although there's a change in the codon sequence from AAG to AAA, both of these codons produce the same amino acid, lysine. This mutation is a transition because a change is happening between purines. Here with the UNO cards, you can see there's no color change, which signifies how there's no change in the amino acids. The third mutation is the nonsense mutation. This mutation is caused because adenine is getting substituted with thymine in the DNA sequence, which is transcribed into uracil in the mRNA sequence. This mutation is a transversion because adenine is purine and is getting substituted by thymine, which is a pyrimidine. The original codon sequence AAG turns into UAG, which produces a stop codon. Here, with the UNO card, instead of having our 5th amino acid, we're having an early stop here. The fourth mutation is a read-through mutation. This mutation is caused because adenine is substituted with cytosine. The mutation here is a transversion because adenine is a purine and cytosine is a pyrimidine. The original codon sequence of UAA, which is a stop codon, turns into UAC, which is a codon for tyrosine. Essentially, the mutation lets translation continue past the 5th amino acid, which is why we're seeing the UNO cards go all the way up to 9 amino acids. Here's my references. Thank you.